Welcome back everyone. So let's continue the types of mapping or function that we have. So the second type of mapping that we have is called the onto mapping or surjective map. Now onto, take note, this is different from one to one. Do not, one to one, like I said, when I was saying one to one, I said one to one is injective, onto is for subjective. Don't try to take it together, like maybe you are trying to relate onto to one to one. They are different. So now, when did I say a function or a mapping is one to one? Now, a mapping from A to B, a function, a mapping from A to B. From what we did at the beginning of the class, I said when you have something like this, A is called the domain, then B is called the codomain. Now, a function or a mapping is said to be onto or surjective if all the elements in the codomain has a pre-image in the domain. Let me write it. A function or a mapping is said to be surjective if every element of the codomain has a pre-image in the domain. Now, what does this mean? This means that given any element, let's say y, and I said B is the codomain. Given element y inside the codomain, there exists an element x in the domain such that f of x equals to y. So this is just a onto or a surjective map of function. Now, take note of this. The range of a given surjective map must be equals to the codomain. The range. Another way that I can identify onto a surjective mapping is the range of f must be equals to codomain of f. So if this is satisfied, then this function will be surjective, or this map will be surjective. Anyone want to use? Let's take an example. Let's have a function with domain A, codomain B, from a function from A to B. Let's assume that all the elements here we have A, B, C, D, and this is E, F, G, H, I. So now let's look at this. E, F, G, H. Let's just say E, F, G, H. Now A is mapping to E. Let's assume B maps to F. Let's assume B maps to H. Then let's assume D maps to G. So now look at this. Is this function an onto function? Look at our codomain. I said a function is said to be surjective, or a map is said to be surjective if every element in the codomain has a pre-image. Look at this. These are the elements in the codomain. We have E, F, G, H. Each of these elements has a pre-image. Look at this now. E is an image. The pre-image of E is A. F is an image. The pre-image of F is C. G is an image. The pre-image of G is what? D. H is an image. The pre-image of H is B. So since, when you notice again, we have used all the elements in the codomain. All of these elements, we are using it. So, and I explained the range for us. I said the range is a subset, right? In this case now, the range of this function will now be what? What will be the range? the range is just, now I told you that it's a set that contains all the images. So the first image we have here is E, because A is mapping to E. The second image we have here is H. Then we have F. Then we have G. Now look at this. All the elements in the range is what? E, H, F, G, which is what? Equals to the codomain. Since the range is equals to codomain, therefore this map or this function is a surjective or an onto function or map. Let's take another example. Let's have a function or a map from real numbers to real numbers defined as f of x equals to x squared. Now let's consider this question. Can we say this function is, now the question is f where, don't forget, where x is an element in real numbers. Look at this. So the question is f an onto map? Now let's look at this question. Can we say this is an onto map? We know that R here represents sets of real numbers. In set of real numbers, we can have integers, we can have rational numbers, we can have irrational numbers, we can have whole numbers, and so on like that. So now, is this an onto map? Let's consider that. Now, how am I going to do this? Solution to this question. How do I do this? You know, I told us that first of all, for a function to be onto, all the elements in the codomain must have a pre-image. R here is our what? Is our codomain. Now, R is representing set of real numbers. Is all the elements here having a codomain? I know we have f of x is equals to what? Is equals to x squared. Suppose I say f of x equals to, let's say, 9. If I have f of x equals to 9, take note, 9 here is an image of what? Is an image of a pre-image x. Now, suppose f of x equals to 9. Does 9 have a pre-image? Does 9 have a pre-image in x? Now, what do I mean by this? You know, we say f of x is equals to what? X squared, right? So it means we're having x squared equals to 9. And from the knowledge we know about when we're having let's say a quadratic equation, we can just take the square root of both sides. So taking the square root of both sides, taking the square root of both sides, we are going to have square root x squared is equals to square root 9. Plus, don't forget your plus or minus sign. You know, square root takes the form plus or minus. So this implies that what? X is equals to what? Plus or minus what? 3. So it means that the pre-images of 9, they are what? Minus 3 and 3. 9 has images. 9 has pre-images minus 9 and 3. In case you don't understand what pre-images is, let's just come out to what pre-images. Pre-image are elements in the domain. They are elements in the domain. 9 is an element in the codomain. I took 9, that's why I said, you know, I said f of x here is representing the image. So because I know 9 is an image, I want to find the pre-image of 9. So I have x now equals to plus or minus 3 after solving it. This means that what? The pre-image of 9, they are plus or minus 3. So we have done the first case. Suppose I use another number. Let's say I take minus 9. If f of y equals to minus 9. Now, what I want to do is, I want to know if minus 9 has an image in this map or function. How do I do that? We are going to have, we have f of y equals to minus 9, right? So, since we know f of x is x squared, so if f of x is x squared, or let's just maintain our x, so we are not going to get confused. Since f of x equals to x squared, so this implies that x squared will be equals to what? Minus what? Minus 9. Don't forget, x is a what? X is a pre-image. X is a pre-image. Now, look at this. For us to find x, we can just take the square root of both sides. So we're going to be having x now equals to what? And I have plus or minus root minus 9. We are having square root of a negative number here. And we know that from the definition we have about imaginary number, we said root minus 1 is equals to I. Root minus 1 here, this I here is called the imaginary unit. Imaginary unit. Now, in a complex number is a number in the form. A complex number is a number in the form a plus bi, where a and b are both real numbers. When you find square root of plus or minus root of minus 9, you are going to be getting plus or minus 3i, because we know that root minus 1 is 9 is I. So if root minus 1 is I, therefore root 9 will give us what? 3. And we said minus 9 is an image, x is a pre-image. We are having our domain here as what? Set of real numbers. And we know that set of real numbers cannot contain a complex number. Look at this. We have x equals to minus 3i, x equals to plus 3i. Minus 3i and plus 3i. Okay, let me just adjust it to the front here so that we can have a better look at that. Let's rub off this. So we are going to be having x equals to plus or minus 3i. This implies that x is equals to minus 3i or x equals to 3i plus 3i. Minus 3i and plus 3i, they can never be found in a real number. They can be found in a number called complex number. So since minus 9 has image and pre-images minus 3i and plus 3i, which are not elements of R. You know, I said R is a set of real numbers. It is impossible for us to find complex number inside set of real numbers. So therefore f is not an onto function, or let's say f is not an onto map. You know we said they are just the same. So thank you very much.